This tutorial is for mile marker 2, practice 1, question 5. Just like in question 2, I'm going to show you two different methods for 90-degree rotations. I'm going to show them to you in the opposite order this time, just in case you didn't catch the end of the question 2 video. So you'll see in a second why I put 2 copies of problem 5 here. So remember, we said rotations have a degree and a direction, and that when we're talking about rotations, they're either going to go clockwise or counterclockwise. And again, I always write out to the side which direction my rotation is going to go. So if we read problem 5, in question 5, it says, rotate the triangle 90 degrees counterclockwise about the origin. Label the image of triangle ABC. So the method I'm going to show you is easiest to do for like a 90 or a 180 or a 270 degree rotation. So let's go ahead and what we're going to actually do is rotate the paper instead of trying to complete the rotation. Because you don't have 2 copies of your problem, you'll need to write down the coordinates, probably one at a time. So again, we're going counterclockwise, and I'm going to take the question, and for you, this would be your whole paper, and rotate that 90 degrees counterclockwise. And what we see is our triangle is now in the position that it should appear in our image. So it would be really easy for me to just graph that onto the other one, but since you don't have to graph, and you out 2 copies, I suppose, of the practice, what I would do if I were you is I might do this one point at a time so I don't make a mistake and just write out the coordinates. So if you look at where A is, the A used to be in the first quadrant, it's now in the second quadrant, and it's at the ordered pair, or sorry, the coordinate -2, 7. So that's going to be the location of A prime. So A prime will appear at -2, 7. B, we can see, used to be on the x-axis, but now B is on our y-axis. So B is at the point 0, it looks like, is that a 5? 0, 5. So that means that B prime should be at 0, 5. And then lastly, C. C was in our 4th quadrant, but when we rotated it 90 degrees counterclockwise, it's going to move into quadrant 1. So C is at the point 2, 8. So C prime, when we graph this, should be at 2, 8. So now if you're following along with me, you would rotate your paper back to its original position and just graph those points. So again, we said that we're going to see A at -2, 7. And remember, when you label that, because it's the image, use the prime symbol. B is at 0, 5. Sorry, B prime. And C at 2, 8. C prime. And then I do want to see that you connect those points, because it's not a rotation of a triangle unless you make a triangle. So I don't want to see just points A prime, B prime, C prime. I want to see the connection. I obviously didn't use a ruler just now, so it's okay if you don't use a ruler. I'm going to take you through one more way to do this 90-degree rotation. There's more than 2 ways, but these are probably 2 of the easier ways. So another way is to just rotate this point by point. And what stands out to me is that if I look at this, point B is going to be the easiest point to rotate 90 degrees because it's on the x-axis. So a 90-degree rotation counterclockwise is going to put it on the y-axis. And it's always going to be the same distance from the point of rotation, which is the origin. So if I look over here and I see that if I see that B is 1, 2, 3, 4, 5 units to the right, so its x coordinate is 5, that's going to be its y coordinate when we rotate it. So 1, 2, 3, 4, 5. All right. So here's our B prime. So anything on an axis in a 90-degree rotation should end up on another axis. So points A and C are a little harder. Some people who are really visual will just kind of observe how the distance, or sorry, how to get from B to A, and they'll kind of recreate that, but you still have to rotate that. I don't like to do that. So what I'm going to do here is I'm going to connect A to the axis. So I'm going to, let's see, I'm going to use a different color, and I'm going to connect A to the x-axis. It doesn't matter if I connected it to the x or the y. It's just closer to the x right now. I'm going to kind of do this using a right triangle, and I'm not even going to draw in the hypotenuse. I'm just going to draw in the legs of this right triangle. So if I notice, I'm going over 1, 2, 3, 4, 5, 6, 7 units to get to A, and then I'm going up 2 units. So just like the point B rotated to the y-axis, I could actually rotate the line that I just drew on the x-axis up to the y. So if I do that, that's going to put me up 1, 2, 3, 4, 5, 6, 7. And then if I think about this, if A was in quadrant 1, and remember this is quadrant 1, when I rotate it 90 degrees counterclockwise, it's going to have to end up in quadrant 2. So if A is 2 units above the x-axis, it's now going to be 2 units to the left of the y-axis up here. So that's going to be our A prime. All right, so from here, you have a couple choices. You could just look at the original triangle and think about the distance from B to C. I don't like to do that, though. I always make mistakes when I do that. So let's just try that same method with point C. So for point C, I'm going to use a different color. I'm now, from the origin, going over 1, 2, 3, 4, 5, 6, 7, that was 7, 8 units. So 8 units over and then 2 down. So point C right now is in quadrant 4. So remember, this is quadrant 4. When I rotate it 90 degrees counterclockwise, it's going to rotate into quadrant 1. So I can use that to help me. So again, I'm just going to, this line that I drew on the x-axis, I'm going to rotate that line up to the y-axis, and I really shouldn't say up, I should say counterclockwise to the y-axis. So now I'm rotating it up here, over here, up to 8. And then we said right now that C is 2 units below the x-axis. When I rotate that counterclockwise, that's going to become 2 units to the right of the y-axis. So if you imagine that those are the legs of a right triangle, we essentially just rotated this triangle. So here's our C prime. So if you watch the earlier way to solve this problem, we should get the same triangle. This one's a little harder to look at because it's so many colors, but let's see if we can kind of connect this here. Oh, it would be helpful if I had a ruler, huh? All right, and that's where our triangle should appear, triangle A prime, B prime, C prime. Don't forget when you're doing the mile marker to connect those points.